that started too. So as you look at this assignment, first off, if we are reading our vocabulary, the words that you are looking at as you look at your notes. Sorry about that. So, similar polygons have the same shape as you were looking at, not necessarily the same size. This is the symbol that we will use. It's just this squiggly equal, kind of a squiggle line. It means similar to. So you could write triangle ABC is similar to triangle DEF. So as you're filling in your blank, right there, in that blank, in your notes, right here, not necessarily the same size is the word you were looking for, okay? A dilation is a transformation that stretches or shrinks a figure in relation to the center, okay? It also moves the figure away from the center or closer. To move it away, this is when the value of k is going to be greater than 1. Meaning, if I multiply by 1.5, or by 2, or by 3, okay? So closer to the, you should have center, is what you were filling in there, right? It goes away if k is greater than 1, and it goes closer if the value is between 1 and 0. So it's going to get closer. And so this big quiz on Friday, the transformation quiz that we're going to be taking this Friday, when we take that quiz, I have a question on there that says, when you have a dilation of size 2, what are 2 things that happen? And I had people say, it got bigger, and it's similar. Well, bigger and similar, those are kind of the same thing, right? The size changes. What I'm really looking for is that it doubled or it got larger anytime k is greater than 1, and it moved farther away from the center. And our center is always going to be 0, 0. So the key thing is with the dilation, it's moving away from that center point, or it's moving closer to it. The last one for the vocab that you are looking at, a scale factor determines how much larger or smaller a figure will get. It also determines the distance that a figure moves in a dilation. So that scale factor determines, if we are looking, how much larger or smaller. Larger is when, anytime, again, when k is greater than 1. That's when our dilation is going to get bigger. The smaller is when it gets closer. Anytime you have a fraction or a decimal. Okay? If you look at that next picture going down in your notes, okay, this is where a lot of people think of dilation. Sanjay, would you please read where it says this example?
This is an example of the dilation of the pupil in an eye. The pupil stays the same shape, but it gets bigger each time, depending on the light.
So if we are looking at that, it says, look at the dilation on the right. What happened to the triangle? How does its size change? If we start at PQR and we go to P prime, so we know this is our original, right? And the reason we know it's the original is because it's PQR and this is P prime. So this is called the image. Okay, this is the new figure. So it says, how does the shape change? It gets bigger, right? And it is also farther from point C in this case. Does the orientation change? Nick, face forward, please. Does the orientation change? No. PQR, P prime, Q prime, R prime. Does the orientation change? No. Only time, raise your hand, that orientation changes is, Kylie? Reflection. Only reflection. So orientation does not change. How does the location change? What could we say, Lucas?
It gets bigger, so the points are further out from the center.
In this case, it's going to be farther from the center, and our center is at C. At this one, ours is always going to be in a coordinate plane, but this one they just drew it to kind of just show you a picture. In geometry, in a couple of years, you will be doing this one in a not on a coordinate plane. You have to do scale changes. So as you take a look at this next one in your notes, after next page, they give us the quadrilateral ABCD. They give us the points, and they say use a dilation scale factor 2. So what I want you to do is right above A, I want you to tell me where A prime is going to be. Right above B, I want you to tell me where B prime is. C, I want you to tell me where C prime is. And we're going to do D over here. Now, when it says using a scale factor of 2, what that means is we're taking each point and multiplying it by 2. So scale factor 2 means this. X, Y changes to 2x, comma, 2y. Okay, that's what that dilation scale factor means. Okay, so each one, first thing I want you to do before we plot it, I want you to label those new points. So, start now, Jacob. A is located where? No, you're going to multiply by 2. Not negative 6, 0. Abby, B prime. Yes. C prime, Ben. Two times both. So where's it going to be? 2 and 2. Buena. D prime. Please, if you have not already plotted those, do that now. So putting your A prime, putting your B prime, -4. Please connect them so that as you are looking at those. So, as you look at yours, should the shape change at all? No. So if I'm looking at this one, and I am drawing mine, and I go here, and I go here, and I place my C point at this point, and you go, I don't think she'll mark it wrong. Jack, have you already graphed yours? Okay, so I drew it like this. That's not the same shape anymore, right? Because I placed this at the wrong point, C prime. So it is very important, and you being precise, that you go to this point and go here. It should be twice as large going out from the center. And you not being really careful on your points is going to make a difference. So, how does the shape change? It is twice as large. Okay. And it is farther.
Oh, the shape doesn't change.
Ah. So, how does the shape change?
It doesn't.
It doesn't. Same shape. How does the size change? It gets bigger. Twice as large, right? Twice meaning multiply by 2. Orientation. A, B, C, D. A prime, B prime, C prime, D prime. Or how does the orientation change? It doesn't. Stays the same. Doesn't change. Right? How does its location change? This is where, Lucas, we are going to put. It is farther from the center. And our center, 0, 0. Or if you wanted to tell me the origin. So from here, okay, from the origin, not original, from the origin. So from 0, 0, where point C is located at 1, 1, now it's at 2, 2. Where point B was, negative 2, 3, it is now twice as far from that origin, okay? Are the two quadrilaterals similar or are they congruent? We should say similar. So we are going to write A, B, C, D is similar to A prime, B prime, C prime, D prime. Okay? Please put that right in your notes. Okay? So the next one down in your notes asks you to first draw this LMN. Okay? It's a triangle. So right below this, I want you to tell me L prime. And what they're telling us is that K is 4. So what that means is my XY is going to change with a dilation scale factor 4. 4x, comma, 4y. So please tell me M prime and N prime and graph both. Okay? And you can always connect those two. Okay? Connect it, make a triangle. Whitney, L prime is going to be where?
8.
Yep.
-4.
Jack. Deal. M prime. 12, 8. N prime, Jessica.
16, 4.
And they all fit because you're 16, 4, right? This is my N prime. 12, 8. Here's my M prime. 8. So I have the one triangle. I also have 2 negative ones. I had 3, 2. So I had L, M, and 4, 1. I am now drawing my larger one. If I would take and measure angles going around there, I should find that the measure of angle N is equal or congruent to the measure of angle N prime. These two should be the exact same angle. And if I look at that kind of going out from, in this case, the origin, as I'm looking at those, I should see that it is quadruple, right? Okay. Yes.
I don't know if you're, I might have but I didn't really catch or know if they're doing it by 2 or 4.
When they tell you the scale factor, that's telling you what you're going to do. So the reason I didn't give you the worksheet that's a 2-step, all of a sudden in there, it says problems like do scale change 4 or 2 or 1/2. And I had people, if I were you, I guess you'd have lots of questions for me. Go, wait, we haven't done this. So that's why we're doing today's lesson, and then we're going to get that one for tomorrow. Now, I think I understood that Thursday is track in the afternoon, 150 for 7th and 8th graders. I don't think the baseball, I think this week it's 8th grade that gets out in the morning and not 7th grade. But I know you have lots of things going on if it's not for school activities and other things, so just make sure you're keeping up with this. All right, so here we're going to draw a triangle DEF. This time it says scale factor is 1/3. So please put out in front x comma y equals, we're going to put 1/3 x and 1/3 y. And I have people go, what? I don't know how to do 1/3. Remember, this just means divide x by 3. So if you wanted to think of it this way, as x divided by 3 and y divided by 3, that is the same thing, right? As multiplied by 1/3. D prime write out the D prime, the E prime, and the F prime. You're going to divide them each by 3. We are also graphing DEF, and I'll give you a minute to write those down, and I'm going to call them. Okay? Yep.
Will we ever have like, so it will be like divide by like 17 divided by 3? Will we ever have that?
No, I will not give you ugly ones.
Okay.
Maybe in geometry, but no, they're not that mean either.
Okay.
This is a pretty big triangle, the original DEF. Okay? So it should be making it much smaller. New points. Ellen, are you ready? D prime? Oh, -1, 2. Taylor, how about E prime? Careful. Divide by 3.
Oh,
1, 4. Frickin' F prime.
F prime would be
2, 0. So I am now plotting my new points. -1, 2. It's getting quite a bit smaller, right? D prime. 1, 4. E prime. And 2, 0. So, what you're going to be doing in your homework, we got one other thing quickly in your notes. So, the negative dilation. So it says when an image is the opposite side of the center of that dilation, from the original to the image. So I want you, as you watch this, it's not, I know it might seem kind of long. It's not that bad. You're going to get started on homework really soon. But we're going to watch this first. And if you have questions, just be ready.
If the scale factor of a dilation is negative. In this lesson, you will learn how to draw an image of dilation with a negative scale factor by using the center of dilation at the origin on the coordinate plane, not going through the center to a parallel line, and a segment going through the center to the same line. In this diagram, you see segment AB is the pre-image, and segment A', B' is the image under dilation with a center at C. Notice that AB and A', B' are parallel to each other because they do not go through the center, where CA and C'A' are on the same line. You should also notice that the center, the image vertex, and the pre-image vertex are always collinear in a dilation, so CA and A' will be on the same line. And the length from the center to the image vertex is the scale factor K times as large as the length from the center to the pre-image vertex. In this case, CA' is equal to K times as long as CA. If we need to draw an image of dilation of BIG with a center of 0, 0 and a scale factor of -1, we will start with our pre-image. Notice our pre-image is on the coordinate plane, so we can work with the vertices of B, I, and G. And here we have B at 0, 1, I at 0, 3, and G at 4, 1. In order to find the coordinates of the image, we need to multiply each vertex by -1. When we do that, we get B' at 0, -1,
So the only thing
I'
that's
at
different
0,
than
-3,
multiplying by our
and G' at -4, -1.
positive one,
And we can plot each of those vertices and
Nick, I
connect
need your
them to
attention.
have the image. We have B', I', G' is the image under dilation. The corresponding segments BI and B'I' are on the same line because the pre-image segments go through the center, where IG and I'G' are parallel to each other. You should also notice that the orientation of the image has changed. This is the first time we've seen that in a dilation. If we are asked to draw the image of dilation of CAT with a center at P and a scale factor of -2, we again must start with our pre-image. In this case, our pre-image is not on the coordinate plane. We have the center point P and the pre-image CAT. In order to find where the image is going to be located based on the center, we need to draw lines that go from our center through each vertex of our pre-image. Since we're dealing with a scale factor of -2, negative means the opposite of. So our image vertices are going to be in the opposite direction
as
on
you're
the
writing
same
down,
line.
what are
So
our
our
notes
lines
for what
need
is
to go through
happening
the
when we
center
do
in
that
both
negative?
directions. We can use a ruler to find the length of PC, PT, and PA,
Anytime it's
and
negative,
multiply
it's
each
going
of
to
them by
be
2 to find the length of the image segments. So PT is 1 centimeter long, PA is 3.6 centimeters long, and PC is 3 centimeters long.
Now, ours is not going to be so much this part as it is more here. So
We
this
have
is the
L
part I want
prime
you
at
to take a look
-1,
at.
2, I prime at -2, 5, O prime at -4, 5, and N prime at -5, 2. And notice again, because this is a negative scale factor, our image vertices are in the opposite direction from the center of our pre-image vertices.
So if you were going to put it in your notes right now, important information from the video, negative dilation is doing what? Opposite, and then opposite side of it, of our dilation from our pre-image if we are looking at it. And so if I'm going LION, I am going, my orientation, does it change? LION is going clockwise. What is this one? LION. So if I'm going here, I'm going counterclockwise, right? L to I to O to N. How about here? The orientation, Nick, I need you facing forward. The orientation doesn't change. What's happening is that it moves to the opposite quadrant, right? But our orientation around this figure, LION, if I'm looking at it, okay? It flips the thing totally. It's like doing two reflections when we think about that, right? And then the size change, okay?
You should also notice that L prime, I prime, O prime, N prime is 1/2 the size of LION. In other words, it is equal to the absolute value of -1/2 times as large as LION. We've looked at 3 different dilations with a negative scale factor. In each of them, they had specific properties that existed. The first one had a scale factor of -1.
Key thing we want to look at
Each
is
side
this last part.
the scale factor by using the center of dilation at the origin on the coordinate plane.
So when we are looking at ours, you should have written down the 2 important things is that it is going to put it in the opposite quadrant, right? If we're going to put. And the other important information is that it's making all the numbers the exact opposite. Orientation is still going to be the same. The last one is looking at this. And they're asking you if it is proportional. So,
Looks like Corey.
okay, so it says look at these 2. It says a dilated image is similar to the original. Look at the 2 TVs. Are they similar? If so, what is the scale factor? So if I'm asking you to figure out the scale factor, meaning I may be starting at the large TV and going to the small one, how could we figure out our scale factor? Anyone have any ideas you were looking at it?
Divide the big one by the small one.
So we could take the big number and divide it by the small number. Could I divide the small number by the larger number? Depending on which way I'm moving, right? So they are similar as we look at them. And as we are looking at this, if I'm going small to large, so if I was going from the small one to the large one, I take either the 40, right? And I divide it by 24. And if I simplify that by dividing them both by 8, that's how we got 5/3. If I'm starting at the small side and I want to go to the large one, from the large to the small, then just the opposite. I put the large in the denominator. So if I'm going large to small, I'm going from the large one to the small one. I'm going to take, and it doesn't matter if I use the 18 or if I use the 24. And if I put that over 30, again, if I divide them both by 6, I'm still going to get 3/5. So they are similar. The key thing is, are you going from large to small or small to large? Now, your homework, if you turn 2, and hopefully we get a pretty good start. So, on Friday, how many of you got that whole about 40 minutes on our program with the sub? If you didn't and you decided, I'm going to work on other homework, you're getting that 40 minutes in on your own. So when I look at from last week, Friday, and you were here, you weren't absent, and you worked on homework, and you didn't get in, it keeps track of how many minutes you're on for me. So, if you didn't do that, like, we're going to be on there again on Wednesday, and we're going to be doing this a few other times when we have a sub, just because it's easier than always doing the lesson. If you don't get on, you want to make sure you check with me, and we'll try and figure out your devices. But if you decide to do it for homework, or the sub says, you can use homework or do this, I'm assigning that for you to do at that time. So we're going to have at least 2 times a week where I'm trying to get you on. You really should be doing like a good 10 minutes at a time, 10 to 12 minutes, and then another time 10 to 12 minutes. So on that 40, I figure that's kind of, if we do it for the period, that's kind of taking care of it. Yeah. Did you remember how we got, how I gave you that from, you had to go back? Did you try and save it into like a bookmark? So we might want to make sure you do that before also. Yeah. If you were absent, you don't have to, but if you were here. So take a look. I am going to be looking at those, so kind of taking a look at your minutes. So in your homework tonight, the first one, I think it's helpful to put your new points below each one. Some of you are going to find you don't really need this. You're able to just graph them. But I do think it's helpful for some of you to put those. Number 3, please turn and look at number 3. You can go wherever you want. So number 3, what's going to happen with the scale factor of 1.25? Are you going to get decimals? Yes. So you're going to get decimals or fractions. That's okay. So you are going to take on your calculator, and you're going to take, to get a prime, right, you're going to take 2 times 1.25. And then you're going to take the second, or that negative 2, I guess it was, times 1.25. That's going to give you your new a prime. Does that make sense to everyone? You're going to multiply. Then you're going to take 8 times 1.25 to get the y coordinate. Okay? So you still should be getting that new point. When you get down to question number 5, you start doing combinations. Okay? Your quiz on Wednesday is going to be doing 2 or 3 steps. It will not have size change on it, I don't think. It just has the rotation, dilate, translate, okay? So this one, after you draw this original figure, number 5, A, B, C, D, this next thing, you're going to rotate it 90 degrees clockwise. Then you're going to reflect it over the y-axis. And then you're going to dilate it, which means, Nick, I need your attention here. This will have 4 different quadrilaterals when I get to number 5. Right? I need to see 4 on your paper. I need to see the original one. Then I need to see you rotating at 90. So my hint is, after you have these points, I would maybe list like the A prime, because, 90 clockwise. Oh yeah, that's when X, Y changes how? So if it's clockwise, it is Y. And so I might even want to put this rule down to help me. So that when I list A prime, I'm going to list that. Then I'm going to have my A double prime. That's the 3rd one. And then this is going to be my A triple prime. Okay? So I will help you as you get started.